sorry.
Oh, no, you're fine. I just have just enough calculators for this whole class. All right. So, to clear out your calculator again, second plus 712.
Obviously, it's not there.
But what that does is it clears out. If you changed your window, it clears that out. Anything that you did to your calculator, it brings it back to factory settings. Okay. So we left off yesterday with intercept form, and we had plugged in negative. And then in the first set of parentheses, we had x minus 2. What, the silver edition?
Yeah, that is so cool.
And then in the second set of parentheses, we had x plus 4. So your y equals should look like this.
Wait, what page was that on?
Wait, would this be on the
We're still on page 70, that one we were doing with the different forms. We're on that last form, intercept form. Okay, so we talked yesterday that if we're in intercept form, this should give us the intercepts. Okay, so it does. So I'm going to show you how to get the intercepts on the calculator, and then I'm going to show you how to get the intercepts from just looking at the equation. Okay, because this is negative, what should my graph look like?
Maximum.
It should have a maximum. It should be going down. So when you hit graph, here's your graph. You put it in the y equals?
Oh no.
Okay, we got to back up for Kenley because she lost her mind today. Here's your equation, friend.
I swear I put it in.
She's like, I've got nothing. That's your equation? No.
Will this be on the
You look drunk today.
all three of the
Little.
Please say no. Please say no.
It's not that you're going to see all three forms. Like, I might give you a quadratic in any one of those forms and say, find me the vertex.
We are very explicit.
And I'll have to find the vertex.
Okay, are we good now, Kenley? All right. Yes.
You have to tell us before you start recording because we say very explicit.
We really do.
Watch your language. All right. Chill out. Breathe. I know it's Friday. It's been a long week. Okay. So, all right, Giggles. 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 Calm down, Giggles. All right.
How long ago was that?
Okay, shush. Let's get through this.
Thank you. Okay. Y'all said that this was too close to the top of the screen. So I showed you yesterday, you can go to the window and you can adjust anything you want to on the window. I want to see higher. So what axis goes up? Y goes up. And if I want higher, I need to change Y max. Y min goes down, Y max goes up. X min goes to the left, X max goes to the right. Okay, so we're going to scroll down to Y max, and we changed it to 20 yesterday.
How about if you could see it just one?
You can just leave it. Okay. So when I change my Y, instead of having 20 spaces or 10 spaces, I now have 20. So it's pushed your graph down. This is still the same as your original picture, though. It still has the same vertex. It still has the same x-intercepts. It's just you're looking at it differently because you've extended the window. Okay. So we said we have a maximum. So we're going to go to second trace. And we want choice number 4. Notice, when you do this, it automatically gives you your y-intercept. That's where every graph typically starts. So you can already write down your y-intercept under your miscellaneous. So your y-intercept is at 8 or 0,8, either way. Okay, when we're trying to find a maximum, you want to get as close as possible to where you think the maximum is. Okay, So right now I'm guessing my maximum is somewhere between -1 . Once you're there, you need to go a little bit to the left of that. So I suggest 3. You can go more. Once you go left, you hit enter to tell them that's where I want to stop. Go back to the maximum where you think it's at. Now go to the right and hit enter. So what you've just done is you've told your calculator, my maximum should be somewhere in between this and this.
Yes.
Okay, it's somewhere in the middle between those two. So now I want you to guess. So I want you to take it back as close to that maximum as possible and hit enter. -0.999999 is close to what? -1. And my y is at 9. So your vertex is at -1, (9).
-1 and 9.
-1, (9). Okay. What?
Do I put the bracket by -9? I mean 9.
That's something for like.
That's for range and domain. Okay.
So what's the slope? What does that mean?
Slope is the
That's your.
X, like,
We don't have slope with quadratics. That's only
I
with the
mean, we kind
linear.
of do.
You kind of don't.
You do, but it's not a constant. It's not a constant. Yes, ma'am.
So in order to do this, they would give us like the form, or like would we have to do this with a word problem?
Oh, we're gonna do word problems.
Oh, what?
No.
We're not gonna do those till the next unit, though.
I thought you said to next year.
No. We're gonna do word problems.
Yeah.
But normally in the word problems, they give you the equation. So all you have to do is plug it into y equals and do this. Okay. So it's more deciphering. When we get to word problems, it's more deciphering if it says how high is the object. What am I looking for? Do I need the vertex? Do I need to know when it hits the ground? Do I need to know where it starts? It's more of that type of thing when we get into the word problems. Okay. So we have a maximum at -1, 9, which means my axis of symmetry is at x equals -1. Okay. To find your x-intercepts. Actually, let me show you the short way to do this first. If it works. Okay. I'm going to show you this, but it only works if your graph crosses at an exact number, like 3 or -2. Okay. So if you go to your table, what do we know about an x-intercept?
It crosses the X.
Crosses the x, which means my y value should be
8.
0. If I'm on my x-axis, my y value should be 0.
Oh, yeah, I get it.
Tells me.
So my first x-intercept is at 2. Okay, so that's your roots under miscellaneous. We've got one at 2. Where should my other one be looking at my graph? It should be in the negative something. So when I go to my table, we need to go to the negatives.
-4.
-4. So it crosses at 2, -4.
I thought the easy way was when you look at
Oh, I feel it.
If you look at the what?
That's the answer.
I think it's two and
Just hold on a second, Elijah. You're going way too fast for me.
Yeah. Don't you eat 2 and -4? You said 2,
I 2 and -4, yes. I put a comma in between to separate them. Yes, it's not a point at 2, -4. You're right. Okay, so the thing is, listen. Okay. So the thing is, if it would end up being an x-intercept at 3.5, you can't find that from your table. It's not going to show up because your table only shows you whole numbers. So if you have something like we did in standard form, where we ended up with 1.27, you're never going to find that on the table, which is why I show you how to do it this way. So let's try it this way again, just with one of them. Okay, so hit second trace. We need a 0 to find your x-intercept. So you want choice number 2. Do you want to find the one on the left or the one on the right? Left. So again, just like your vertex, get it as close to where you think it is. Now I need you to go a little bit to the left. Hit enter. Go back to it. Go a little bit to the right now. Hit enter. And go back to it one more time. And hit enter. You should end up with the same exact answer you just got from the table. -4,
Well, if you're
okay. So again, the table is only good if it actually lands at a whole number.
that's what you get.
It's called karma.
There you go.
Okay, so we said that intercept form should give us our roots. So take a look at the equation that you were given. We had x minus 2 and x plus 4. Take a look at your answers for your x-intercept. We had positive 2 and negative 4.
You have negative on the outside.
It has nothing to do with the negative on the outside.
Oh, never mind.
Okay, as soon as you get intercept form, which is what you do when you factor, the way to actually get these roots, so we have x minus 2. You would set that equal to 0. And then solve for x. So you would add 2 to both sides, which is why you get x is positive 2. Yes. Okay. Same thing with 4. If I take x plus 4 and set it equal to 0, we'd have to subtract 4 from both sides, and you end up with -4.
So that's just another way to do it.
Yes, this is just another way to do it. So if you have an equation in intercept form to find your x-intercepts, you would just take each set of parentheses and set it equal to 0 and solve. And it gives you the same answer.
Only for the first one.
Only the intercept form, only the x-intercepts. Okay.
Are we reading the graph side?
No. We were supposed to just draw a rough sketch there. I'm not all that concerned at this point. Okay. So the last thing we need to talk about today is this. Recognizing quadratics from a table. If the first difference is the same value, the model will be linear. If the second difference is the same value, the model will be a quadratic. Huh? What? What?
Oh, if it's the same thing.
Okay, so with a linear equation, okay, so if we had something like y equals 2x plus 3, okay, that means, let me pull out my handy dandy graph, okay, that means my graph would start at 3 and it would go up 2 to the right 1. Up 2 to the right 1. Up 2 by the right to the right 1. Up 2 by the right 1. And you would connect the dots. Okay? So there's a constant there that it's changing by 2 each and every time. Okay? Quadratics also have that same constant. But you don't find it in the first part, you'll find it in a second step. So, what I mean by that is we need to find the difference of my y values. So, if I take 10 minus 7, that gives me 3. What happens if I take 10 minus 4? Or I'm sorry, not 10, 7. 7 minus 4, my bad. 3. 4 minus 1. 1 minus -2, 3, and -2 minus -5. Okay. That's my first set of differences. Are they all the same? Yes. So this is linear. If you would plot these, this would draw you a line. Okay. All right, let's move on over to here. We're going to do the same thing. What's 4 minus 3? What's 3 minus 2? What's 2 minus 3? What's 3 minus 6? What's 6 minus 11? Okay.
Non-linear.
It's not linear. Okay. We know it's not linear. Okay. So you can put down here not linear. To find out if it's a quadratic, we're going to do that one more time. So I'm now going to do what's 1 minus 1? 0. What's 1 minus -1?
Zero.
2. What's -1 minus -3? That's 2 again. Remember, minus a negative turns it into plus a positive. And -3 minus a -5. 2. Are all of those numbers exactly the same? No. So this is not quadratic either. Okay. That's all I'm concerned about right now. Can you tell me if it's linear? Can you tell me if it's quadratic? Because linear you learned in Math 1, quadratic you're learning now. Okay. All right. Flip the page. We got 4 more. Okay. So we've got 50 minus 75. -25. We've got 75 minus 100. -25. We've got 100 minus 125. -25. 125 minus 150. -25. And finally, 150 minus 175. Okay. Because all of these numbers match, this is linear.
So if it's linear, it's not quadratic.
It's not quadratic.
If it's linear, it's not.
If it's linear, it's not quadratic.
Can you go like the first step, the second step, and ain't there like a name for the third step too? 'Cause
But we're not concerned about all that. As soon as you find out it's linear, it's a line, so it can't be a quadratic. Okay. I understand that if I would do that again, you'd still end up with the same numbers all over again. But once you're set that it's linear, you stop. You do not continue on. Okay. Any questions right now? Was that your question, Kathy?
No, I was gonna ask why do we do the Y, not the X? Why?
The X always goes up by 1.
Yeah.
Okay. So let's scooch over to here. We've got 4 minus 6, -2. We've got 6 minus 6, 0. We've got 6 minus 4, 2. We've got 4 minus 0. And we've got 0 minus -6.
But not linear.
This is not linear.
But
Not. But you think it's a quadratic? All right, let's find out. -2 minus 0. -2. 0 minus 2. -2. 2 minus 4. -2. 4 minus 6. -2.
Quadratic.
So this is a quadratic.
Period.
Period.
Yeah, where'd you get that 6 from?
Where'd I get what? 6?
6 right there.
This 6.
Oh, I was listening.
You're fine.
Right.
Okay. Let's move down here.
Oh, Jesus.
Oh no, we added in decimals. Guess what? You got a calculator in front of your face.
Oh my God.
It's right there. It's pretty.
So 10 minus 2.5. 7.5. 2.5 minus 0. 2.5. 0 minus 2.5. Negative 2.5. 2.5 minus 10. Negative 7.5. And finally, 10 minus 22.5. Negative 12.5. So we know this is not linear. Not linear. Okay? So we take it one more step. 7.5 minus 2.5. 5. 2.5 minus negative 2.5. Negative 2.5 minus negative 7.5. And negative 7.5 minus a negative 12.5. Oh, just wait, because I'm going to show you another cool thing with the calculator after this. Yeah. I love the calculator. It's my favorite. Okay. I want you to also take note of this table. Okay. What do you notice about the y's?
It's the same. It's all even. It divides by the same.
10, 2.5, 0. Then we go back to 2.5, 10. So guess what? This right here is your vertex. That's your vertex. Because on either side, you end up with dots that are a mirror image of each other. Because if I would actually go to graph this, actually, let me do that on here. Okay. If I actually go to graph this, I've got a point at 0, 0. I've got a point at negative 5, 2.5, and I've got one at positive 5, 2.5. And you draw your quadratic.
Lord Jesus.
I still don't think I'm prepared.
Okay, the only problem with that is this one you can clearly see where the vertex is. Okay, because your y's match. This one was also a quadratic. Can I easily see that vertex? No, because my repetition is right here. So my vertex is somewhere in between these 2 points. So it'll be something like 2.5, something. Okay, so you can get a range of where it's at, but you're not always going to get the exact vertex.
So you have to put these in your calculator.
Yeah, Bree, can you turn for it on? I didn't want to be the one that said it.
Why, are you getting cold now?
Yes.
All right.
So I'm the only one that.
Yeah, I was feeling it at first.
Elijah asked for it too.
No,
I asked for
you
it
wearing
too.
shorts.
Okay.
What do I want that for?
Okay, let's finish this. Negative 27 minus a negative 8. 19. Negative 19. Negative 8 minus a negative 1. Negative 7.
No, it's quadratic.
It's not how y'all.
What 8 minus 1?
Yes,
Negative 8 minus negative 1.
No, not the answer.
How did you?
So
I was looking at 8 minus 2.
Negative 1 minus 0. Negative 1. 0 minus 1. Negative 1. 1 minus 8. Negative 7. So this is not linear. Maybe. Maybe not.
Yeah, it's probably not. This is the last one.
Okay. Negative 19 minus a negative 7. This should be negative 12. Remember, minus a negative turns that 7 to a positive. So you technically have negative 19 plus 7, which makes that a negative 12. Negative 7 minus a negative 1. Negative 6.
Can it,
Quadratic?
can it do that?
What? Dude, no.
You can't divide it by.
Yeah, you can't like divide it and like
No. They have to be exactly the same.
Then what was the one that that you're able to divide? Because you can do one like that.
I want you to not focus on that right now. Please don't focus on that right now because you're going to have your head going everywhere and then some. And it's already doing that. I know it. Okay. So
That was not it.
as soon as these two answers don't match, you can stop. We know it's not a quadratic. Okay. So there will be points on your test where you'll have to compare a graph to a table. Okay. It's easier to compare a graph to a graph. So you can actually identify what your table is and get the equation so then you can make a graph. So what I mean by that, we're going to go back up to this one, okay? So I'm going to switch to the calculator, okay? But we're going to plug in these points here, okay? So let me switch back. Whoops. Yes, clear out your calculators again. So second plus 712. Okay. I gave you the directions on the top of the first table page, so you have them to reference back later. Okay. But you're going to hit stat. Okay. So you're jumping into the statistics part of the calculator. That's what stat means, statistics. Okay. You want to edit. Stat is right next to X. Right here, underneath delete.
Oh, yeah, I see that.
Got it? Anybody else need help finding that? Help each other out here, okay? So here's stat. You want to edit. When you edit, it brings up lists. Okay. I don't know if anybody showed you how to do mean, median, mode, and range on here. And your 5-number summary. This is where you would go to do all that. Okay, this is where you would go to do all that. But we can also do other things with this. So in list 1, I want you to put all of your X values for that chart. So 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. 6, enter. Then I want you to scooch on over and hit right and go over to list 2. In list 2, you're going to put all your y values. 4, 6, 6, 4, 0, and -6. Please make sure you put -6 and not -6. Okay.
Would it work or would it be different?
It won't work.
Okay.
It'll error you out that you put in the wrong information.
You have to start all the way over.
No, you just have to fix that part. Okay. Guys, if you ever enter anything wrong, you can simply scroll up and down and you can fix whatever you entered wrong. Okay. So now, once you have it entered, I want you to go back to your statistics page. Okay. To do mean, median, mode, and range, you would go over to calculation and you want one variable stats. Okay. That's how you do your mean, median, mode, and range. What did we decide that this table was? A quadratic. So take a look at choice number 5. This is a quadratic regression. So hit 5. It brings you here. And then hit enter.
Do that one more time.
Wait a minute.
Hold on. You're fine. Hold on. So you would go to statistics. You would scroll over to calculate. We know it's a quadratic because you did all the work to prove that it was a quadratic. So you want choice number 5 and hit enter.
Oh, so the other's like cubic.
Because you entered something in wrong. That's what it's saying. It says error.
That's what it says.
So put out stat, edit, 1, 2, 3, 4, 5, 6, 4, 6, 6, 4, 0, -6. That's not wrong. All right, show me what you're doing from there. I don't know what it's doing. I'll look at that for 1 second. So what you just did is your equation for this table is -1 x squared plus 5x plus 0.
We'll have to find the equation for the table.
How do you spell cooperate?
COOPER.
So now you can plug this into y equals and take a look at the graph.
Could you like plug in like a?
Sound it
Can you plug that
That's
into
the hardest word in the world to me.
That's to the graph.
Cooperate.
You can plug that into y equals and graph it.
No, can you plug
I
one
used to
of these
cast it
points onto the
super-
graph that you
You want to like say how it's spelled?
Uh-huh.
Right in it.
So
I was there that
I gotta figure out what her calculator's doing here for a second. Hold on. Edit. 1, 2. Oh, I see why. Come here. So you can see it in the light. You did list 2 and list 3 instead of list 1 and list 2.
It was like that when I went to it.
Did you clear it out first? Where's list 1?
Me no. I'm gonna break out where.
Why is that like that?
Kelly, it can't be that funny.
You don't need to do that for this test. What calculator is this? I need to take a look at that. Because they did something that removed your list 1 and I'll figure out how to fix it. Okay. All right, so Elijah just asked me, is there a way that I can plug in the equation and see if the table matches my graph? Yes. So if you go to y equals and we typed in, this is -1 x squared, and we said it was plus 5x. plus 0. Okay. If you go to graph, here's your graph.
So
check your table now against the table that you have. Second table.
I don't have that.
Did you plug in -1x squared plus 5x plus 0? That equation that we just got that said that that was your table? That's why. Because we plugged that into y equals. Yes. Okay. So that's a good way to check yourself and make sure you got the right equation. Does it now match my table?
Yeah.
Yes. 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 Okay.
Give me a second.
Wait, what are we
Yes.
No, I have hiccups.
It came from when we did the quadratic regression that your calculator won't let you do.
Oh.
And as soon as I figure out what the heck's going on with that, actually,
Well, mine works for this.
yes. Actually, go grab yourself a different calculator for today because while you guys are quizzing, I'm going to try to check this out and see if I can figure out what's going on. Okay, so on page 73, you should have glued in this page. Calculating steps for finding minima and maxima. It's the same thing as minimum and maximum. Okay, so these are the steps that we took. Okay, except for the fact that I hate this part. I hate Zoom. Don't use Zoom.
Nope.
Zoom sucks.
Zoom does suck.
Okay. Don't use Zoom. So type your equation into y equals. Hit graph to view. Use the window button to decide if you need to move your graph some way so you can see things. Hit second trace. That'll take you to your calculation. You then need to decide, do I need a minimum or a maximum? Move the cursor to the immediate left of the minimum or maximum. Hit enter. Move it to the immediate right. Hit enter. Go back to it. Hit enter. There's your min and max. So all the steps we took on your calculator for min and max, that's here. Okay. I also gave you a calculator to go with that. So if you struggle with finding buttons on your calculator, later on you can go back and color the steps and color the buttons on the calculator that you use. Okay. So you can do that. On this one, this should have been your roots, solutions, or zeros. Again, same steps. Y equals. Hit graph to view. Use your window button. We're not Zoom 6ing anything because it sucks.
You have this on page 74?
There's 2 of them.
There's 2 of them.
Oh.
I just did the same thing too.
I did.
You glued it there.
I did one for minimum and maximum and then one for roots.
Yeah, I was telling you.
You're fine. Okay. Second trace, but this time when you want the roots, you're looking for a 0. Move the cursor to the immediate left of the x-intercept, to the immediate right, go back to it, hit enter, get your x-intercept. And then I put 10, repeat steps 4 through 9 for any additional intercepts. So when you have 2, you might have to do it again. Okay. Questions. Okay, I'm going to give you your quiz. I want you to start it. I want you to try to get as much done as possible. The more we can get done today, the better off we are. However, I will still give you time on Monday to work. Okay.